Hey guys, this is Mr. Grice for Algebra 1, Chapter 13.5 Notes. Today we're talking about combinations and permutations. Our learning target today is to be able to evaluate and solve application problems involving permutations and combinations. So, the first part that we're going to be doing is a review from yesterday where we're talking about the combination formula. Okay? So, the combination formula, or NCR, is n factorial. So n factorial all over n minus r, take the factorial times r factorial. Okay, and remember that n is the whole group, or the big number, and r is the number of the partial group, the small number. Okay, so let's go ahead and do this. Now, anytime we see a problem like this, we automatically want to throw it into the formula right away. Okay? Because even though we can put this in our calculator, we do want to be able to show some of the work that we're putting in there. Okay, now 8, that is the whole, that's the big number, so that is your n, and r right here, that is the part, the small number. Okay, so all the work that we want to see, the 8 factorial stays the same. 8 minus 3 would be 5 factorial and 3 factorial. This is what we have to see. Okay, so we are going to say show this work. Okay, and now from here on, you can just put it in your calculator, find out what it is. Okay, so the way we would do that is we want 8, and then we're going to do the combination of 3, and that gives us the total of what was it? 56. Okay, now let's read a problem where it talks about this. It says, how many groups of 3 can be formed from a group of 9 people? Okay, so right here, this is the whole, and the part right here. So we would write that as 9C3. Okay, so 9 comes on the top, 9 minus 3 over 3. And if you can do that first part in your head, or you'd be like, oh, 9 minus 3, that's 6. You can skip right to that. That's fine with me. Okay, if you can get that, great. All right, and then we're doing 9 CR3, and our total, there would be 84 different ways to do that. Okay, now the next thing we're talking about, now key thing with combination, real quick, order does not matter. Okay, how many groups of 3 people can be formed of a group of 9? It doesn't matter the order of those groups. Okay, but now we're talking about permutations. Permutation order does matter. A lot of times you're going to see this is with people finishing for a race or voting in an election. Order matters in those things. Okay, so the formula for that is very similar to the combination formula, except you're not taking the factorial of the small group again. Okay, so but everything else means the exact same thing. Okay, so let's look at our example. Once again, that's our whole, and this is our part. So when we're doing this into the formula, eight's on top, and then you're doing 8 minus 3. And some of you guys might be able to skip right here and go straight to that step, and that's fine. Okay? Now, some of you can do this in your heads, but let's just imagine. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial means 5 times 4 times 3 times 2 times 1. You can start to cancel these guys out. And then you're left with 8 times 7 times 6. And let's find out something. So we've got 8. Now we're doing NPR. So make sure you're using a different button now. 3 is 336. So 336 is our final answer. Well, what's 8 times 7 times 6? 336. What do you know? Okay, so there's another way to do this without using a calculator, because you can do 8 times 7 in your head. 8 times 7 is 56. Multiply that times 6. 6 times 6, 6. Carry the 3. 30. Okay, so there's multiple ways to get this, and depending on what class you go into, you might have to do this without a calculator. Okay, so just know which one is your whole and what's the part. So we've got 6 on top, and 6 minus 4. 6 minus 4 is 2, so on the bottom, I did 6 minus 4 to get that number. Okay? And then when you plug that into your calculator, you should get 360. Okay? And if you're doing that in your head, 6 times 5 times 4 times 3 times 2 times 1, all over 2 times 1, your 2 cancels and your 1 canceled, and you're left with 30 times 12. Okay? And that's going to get you 360. Okay? So the key thing when you're doing the permutation is that order does matter. Okay? Let's read some problems. If 9 runners compete in a race, how many different ways can first, second, and third place runner finish? Okay. Does order matter? Yes, it does. So order matters, which means we're doing a permutation. Okay. So we got 9 is our big number, and then 1, 2, 3. So 3 is the small number. Okay. So it would be 9p 3, which equals what? Well, 9's on the top, and then remember on the bottom, you have to subtract 2. You have to do 9 minus 3, which gives you 9 factorial and 6 factorial. So then on your calculator, all you gotta do, NPR, 9 NPR3, which gives you 504 different ways that can be done. Okay? Next one, a president, vice president, secretary need to be selected from a group of 9 people. How many different ways can these positions be filled out? Oh, I'm sorry. We forgot to change that shouldn't say 9. Otherwise, it'd be the exact same as the other one. It's going to be a group of 8. Okay? So just know which one is your whole group. And the 3 positions, that's going to be the small group. And does order matter for this? Yeah, order does matter. So it's going to be a permutation. Okay, so we know we're using the P. The whole is 8. The small group is 3. Okay? So following that formula, we know that 8 goes on the top, and 8 minus 3, 8 minus 3 is 5. Okay, and remember, that's the work that we need to see to show that it knows what you're doing. Up. I plugged in the wrong number. 5. Oh wait, no, I did it right the first time. I'm sorry. So you get 336. Trying to be as confusing as possible today. Okay? Alright, let's flip it over. Now, on the back, this is kind of a mixed review of everything that we've talked about so far. Okay, if you want to pause the video and try all of them out yourself to see how you do, go for it. Otherwise, we're going to go over some of these together. Now, key things that we've talked about so far in this chapter, okay, is 1, okay, factorial means that. So if we're doing the factorial of 6, that means 6 times 5 times 4 times 3 times 2 times 1. Okay? If we're talking about a combination, that is the NCR, and there's a specific formula for that, and order does not matter. And the last one we talked about was the permutation, which we did today, the NPR, and order matters. Okay, so you need to know those two things, and you need to know what those formulas are. Okay? All right, let's go over this. So, there are 12 horses competing in a horse race. Only the top 5 fastest horses receive money. How many possible ways can the top 5 horses be placed? Now, here's your question. If you're talking about a race, does order matter? Yes. Okay. So since order matters, this is a permutation. Okay. So we need to know what the whole is and what the part is. So we got 12 P5, and the way that would work, because remember this is the n minus r formula. The top is 12, and then 12 minus 5 is 7. Okay? So even if you could even do this the other way, where you did 12 over 12 factorial divided by 7 factorial, you could do it like that, or if you wanted to do with a permutation, oh, that's a 5. Okay, you're going to get the same answer. Okay, so for those two things, there are 95,040 different ways that can finish. Okay, so think about the horse racing like that, and that's how many different combinations you can have. Okay, now number 2 says a kindergarten teacher tells her students to pick 6 crayons from their 12 crayon box. How many different ways can a student pick from his or her 6 crayons? Okay, now does the order matter here? Order does not matter. Okay, so we're using a combination. Okay, so there's your whole, there's your part. So 12 C 6, and now this is the n over n minus r over r. Okay, so 12 on the top, and then on the bottom, 12 minus 6 is 6. and 6. Okay, that's the work we need to see. And when you plug that into your calculator, you should get 924. Okay? There you go. A student council committee of 8 members needs to select a president, vice president. How many different ways can the selection turn out? Now, you need to decide if order matters or not. There's your whole group. Your partial group is going to be 2 because there's only 2 spots that it can be. So go ahead and pause the video and figure that one out by yourself. Okay, for number 3, order matters. All right, so we use the permutation formula, and then you get a total of 56 different ways that could happen. All right, number 7, how many different ways can 7 books be arranged on a library shelf? Okay, now, looking at the information, they only gave us one number, and there is no small group, okay? So when that happens, if there's only one number, they're talking about doing a factorial, okay? So 7 factorial. Now, remember that 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you do all of that in your calculator, we get a grand total of 5,040. Right, mean, median, and mode. Okay, remember that the median stands for the middle number. And before we do that, we have to put these numbers in order from least to greatest. So you need to be very careful in organizing all of the data. Up 10, 12, 13. Okay, now we had 1, 2, 3, 4, 5, 6, 7, 8. We had 8 numbers. And I have 1, 2, 3, 4, 5, 6, 7, 8. So I did it right. Right? So now we're looking for combinations. We talked about starting from the outside and working your way in. And now we're left with the 8 and 9, which means I want to know what number goes directly in the middle between that. And if you can't figure out in your head, you take the mean of those two, and it is 8.5. Okay? Now, finding the mode is the number that occurs the most. So I have 2 13s and we have 2 10s. It's okay to have 2 modes. That's fine. Remember, mode is the number that you see the most. Okay, and the last one, mean. Mean is the average. Okay, you want to add all of those numbers up. And after you add all those up, you divide by 1, 2, 3, 4, 5, 6, 7, 8. Right, so add those up and divide by 8. You should get an average of 8 because 3 plus 8 plus 13 plus 2 plus 10 plus 12 plus 7 plus 9 is 64. See how we added all of that first? You get 64, and then 64 divided by 8 is 8. All right, some probability. Remember, when we're doing odds against, you want your unwanted over your wanted. Okay? So if we're talking about a 10-sided die, that's 1, 2, 3, 4, we're looking for a multiple of 2. 2, 4, 6, 8, 10. So what are the odds against rolling a multiple of 2? Well, against it would be a 5, 3. You have 5 against, but you have 5, 4. So we talked about how we reduce the fraction, and then you write it as a phrase, that there would be a 1-to-1 odd for that. Okay? Why don't you guys look at the next one? It says, what are the odds in favor of rolling a number less than 8? Okay? So odds in favor are your wanted over your unwanted. So odds in favor, numbers that are less than 8, 1, 2, 3, 4, 5, 6, and 7. So 7 over your unwanted, which would be 3. And can we reduce that? Nope. So 7 to 3. All right. Number 9. Miss Carranza has a box of highlighters in the back of her classroom. She really does, in case you don't know. She has 8 that are yellow, 6 that are orange, 2 that are pink, and 4 that are green. We need to know, first off, what is the total? Well, 8 plus 6 plus 2 plus 4 would give you 20. Okay? So what is the probability that she will reach into the box and grab a pink or a green highlighter? Remember that that's adding. So the probability that she's going to grab a pink would be 2 over 20. Okay? I'll actually write that in pink too, just to be a little bit more fun. Okay? And then the probability that she's going to grab a green highlighter is going to be what? 4 out of 20. So you're going to take those two, the 2 out of 20, we're going to add that with 4 out of 20, and we're going to get a grand total of 6 out of 20. Now, can we reduce that? Yes, we can. And remember that we want decimals too. So divide that out and you should get 0.3. Alright, B. 2 students reach into the highlighter box at different times without looking, and remember, and means to multiply. Pick out one highlighter each. What is the probability that the first student grabs a yellow highlighter and the second student grabs an orange highlighter? Assume that the first student does not return the highlighter by the time the second student grabs a highlighter. Okay? So, be careful because I don't think yours has the word not there. Okay? So, does not return it. So that means the first time when the student goes to grab a yellow highlighter, that there is a 8 out of 20 chance that's going to happen. Okay? But now when it's time to go for the orange, that highlighter hasn't been returned. Oh. So now there's 19. And so there is a 6 out of 19 chance that it's going to get picked. Okay? So 8 over 20, remember that and means to multiply. 8 times 6 is 48. 20 times 19 is 380. and then always reduce your fraction. And then when you divide that out and round it to the second decimal, you should get 0.13. Okay? Well, guys, that's it for Algebra 1, Chapter 13.5 notes. As always, if you have any questions, please come see Ms. Carranza or myself. Otherwise, thanks for watching.